Today I am going to discuss briefly about the eye center method, and after that I will also show the steps which are necessary to do the sums which comes frequently in GATE and ES examinations. So let us first consider a body which is rotating about a fixed point O, and we have taken two different points on the body A and B. As the body is rotating about this fixed point O, all the particles in the body rotates about this point. But if this body traverses a general motion, that is a combination of both translatory as well as rotatory motion, then this body will not be fixed at any point. So it will traverse in this direction. Let us suppose it is traversing in this direction, and also it is also going through a rotating process. Okay, so after some instant of time it will come here, and after some time it will go here. So actually, as in the first case there is a fixed point, but in the later cases there will be no fixed points at a particular instant of time. Let us consider at a particular instant when the body is in this point. In this state, let us consider the 2 points on this body again. Let's this consider as A dash and this one as B dash. So in this, at this particular instant, these 2 points, and not only these points but all other points, will be traversing about a fixed instantaneous point. That is, there will be a center for a particular instant of time for these all the particles of this body. So this instantaneous point about which all the particles of this rotating body is this fixed point about which these particles are rotating is known as eye center. So for a particular instant of time, the point about which all the points of the body is rotating can be termed as a eye center. I can also say it in another way, that is, let us consider a body which is a bit irregularly shaped. Okay, let us consider this body, and it is going through a general motion, that it is having both, that is rotating as well as translatory motions. Okay, and let us consider 2 points A and B. Okay, and this body is also having an instantaneous point, that is, about a point for a certain instant of time all the particles in the body is rotating. Let us consider the velocity of this point is VA, and the requisite direction is shown, and let us consider this one as point B, and its velocity is in this direction, this is VB. So how to calculate the instantaneous center? For that, we have to take perpendicular lines on these velocities. In the along, we have to take a direction which is perpendicular to that of velocities. So we have taken a perpendicular line, and for this one also we will take a perpendicular to this one, that is, this one is 90 degree and this one is 90 degree. Okay, and the point at which this is intersecting, this one is the eye center for the particular instant. Okay, so this is what we can say briefly about eye center. It is not actually important to that extent. We need the process which is needed to solve the problems which comes in GATE or other competitive examinations. Okay, so at first let us take a 4 bar. We are taking a 4 bar mechanism, and one of the link of this mechanism will be fixed. Let us consider this one be fixed. Okay, and this one is link 1, 2, 3, and the fourth link. Okay, now we know that if number of links, if n is the number of links, then the eye center will be given as I is equal to n into n minus 1 by 2. So if number of links is 4, then the eye center will be 4 into 4 minus 1 by 2, that is 6. Okay, after, so for a 4 bar there will be 6 eye centers. Now see how to represent these eye centers. Okay, let us see how to represent these 6 eye centers. So the first one will be I12, then I13, I14, then I23, I24, then I34. Here see that altogether we have got 6 eye centers, 1 2 3 4 5 and 6. Notice how the eye centers are written. Okay, so none of the none of the points are repeated, that is, there is no I11 or I22, I33 or like that, and I12 and I21 are same, I13, I31 is same, that there is no difference between them. Okay, So this is the way in which these I-centers are written. Now we have to find out the I-centers in this 4-bar linkage. Now to find the I-centers, we have to take the two links which are joined. So between 1 and 2, there will be I12. This one is I12 as well as I21. As I have said, there is no difference between them. Between 2 and 3, there is I23. This will be I34, and this one will be I14 or 41, whatever you may say. Okay, so this is done. So from here we will see that how many I centers we have got. So we have got I12, we have got I23, I34 and I14, but we have not got I13 or I24. We will not evaluate it now only, because we will evaluate only the I center which will be required for us to solve the problem. Okay, now let us consider that in a problem it is given that the link 2 is having an angular velocity of omega 2, and it is said us to find the value of omega 3. Okay, so how to do that? See the process. At first write omega 2, then write the I center which is between 2 and the fixed link, that is I12. Then we will write the I center between the two links which are considered. Here we are finding the angular velocity of omega 3 with the help of omega 2, so it will be I23. That is, these two links are under our consideration. So omega 2 I12 I23 equals to omega 3, which is our required angular velocity. Then we will write it into I, there is 3 with respect to the fixed link as I have done in this case, so it will be I13 into I23. Okay, so we know the value of omega 2, it is given I12 I23, the distance between I12 and I23, that is this distance, the length of link 2. Okay, after this omega 3 into I13 I23, that is the distance between I13 and I23, but here we have not got I13, so we have to evaluate I13. Now let's see how to calculate I13. Okay, so for that, at first draw a circle, and within this circle draw what I can say, draw a polygon, which is, and the number of sides of the polygon will be equal to the number of links. Here the number of links is 4, so we will draw a 4-sided, means quadrilateral or something, anything like that you can say. Okay, and denote it with this 4 points, 1 2 3 and 4. Sorry, it is 4. Okay, after this we have to find out 1 3. So how to find out? Connect 1 with 3. Okay, after this thing is done, let's see how to calculate this I13. So there are basically two paths to come from 1 to 3, that is I14 I43 and I12 I23. So at first let us take I14 I43. Okay, so there is I14 I, there is 34 or 43. So at first join these 2 points and then extend it in both the sides. I'm extending in upward direction as well as in downward direction. So this one we have got. Okay, after this we will get another line, that is I12 and I23. So this one is I12 and this is I23. Okay, so we will extend it in both the directions, and by doing that, at a particular point we have got an intersection. This one is I13. Okay, so we have got the value of I13, and the necessary dimensions will be given so that we can calculate the distances from I23 I13 or I13 or I12. So the necessary dimensions will be given and it will be clearer to you if I do a problem to solve it. Okay, so here we can get, we know the value of omega 2, we know the distance between I12 I23, and now we also know the distance between I13 and I23, that is this much distance. This will be calculated, that the necessary dimensions will be given in the problem. Okay, so in this way we will find out the value of omega 3 from this problem. Okay, so if you say me, I will do a sum which will help you to understand this process of doing this sum with I-center methods. And apart from that, I will also do a sum which will also will give you a idea about the direction of motion, that is, if omega 2 is moving in clockwise direction, what will be the angular direction of omega 3 or omega 4, whatever will be asked in the exam. So I will do a sum and I will clear this in the next video. Okay, thank you.